In the name of Almighty God, I am Master Sankasha, and today I want to talk about the Nernst Planck Poisson equation interface. The Nernst Planck Poisson equation interface found under the chemical species transport branch when adding a physics interface is a predefined multi-physics interface for modeling transport of electrolyte species without the otherwise common assumption of local electroneutrality. This allows for simulating charge separating that typically arises close to an electrode surface where ions in the electrolyte are attracted and repelled by on-screen excess charge on the electrode. The charge separation region, also called the diffuse double layer, normally extends a few nanometer away from the electrode surface into the electrolyte. The study of the charge separation is important to applications that consider very thin layers of the electrolytes, such as electrochemical capacitors, atmospheric corrosion problems, ion selective field effect transistors, and nanoelectrochemistry. The Nernst-Planck Poisson equations predefine multiphysics interface adds with migration enabled and which solves for the Nernst-Planck equations without charge neutrality, and the electrostatics interface that solves for the Poisson's equation. A multiphysics node is also added. This node computes the local space charge based on the local concentrations and species charge is in the transfer of diluted species interface and adds it to a Poisson's equations in the electrostatic interface. Finally, a multiphysics node is added that applies the potential dependent variable in the electrostatic interface into the migration term of the transport of diluted species interface. The multiphysics branch in the COMSOL multiphysics reference manual, the transfer of diluted species interface, the electrostatics interface, a diffuse double layer application library path, chemical reaction engineering module, electrokinetic effects slash diffuse double layer. Now I want to talk about the size population balance interface. The size-based population balance interface found in the precipitation and crystallization group of the chemical species transfer branch is used to model a size distribution of particles, droplets, and or bubbles. The interface supports simulation of the space and time-dependent size distribution and mass transfer by convection and diffusion. The interface can be used in zero dimension, one dimension, two dimensions, three dimensions, as well as for axisymmetric component in one dimension and two dimensions. The dependent variables are the population number density of each size interval accounting for interval length and 1 divided by quadratic meter. The minimum number of the dependent variable is 5. Now I want to go through the settings section. The label is a default physics interface name. The name is used primarily as a scope prefix for variables defined by the physics interface. Refer to such physics interface variables in expressions using the pattern name.variable name in order to distinguish between variables belonging to different physics interfaces. The name string must be unique. Only letters, numbers, and underscores are permitted in the name field. The first character must be a letter. The default name for the first physics interface in the model is PBSB. Domain section selection. Select the domains of the model that the population balance model should be applied to. Auto-plane thickness for the two dimensions components. The text field, the default value is 1 meter, defines the parameter for the thickness of the geometry perpendicular to the two-dimensional cross-section area. Both constant and varying thickness are supported. Cross-sectional area for one-dimension component. The text field default value is 1 square meter defines a parameter for the cross-sectional area perpendicular to the one-dimension component. Both constant and varying areas are supported. Consistent stabilization. To display this section, Click the Show button and select Stabilization. Two consistent stabilization methods are available: Streamline diffusion and Crossband diffusion. Both are active by default. When the Streamline diffusion checkbox is selected, a weak artificial diffusion in the streamline direction is added to the transport equation. When the Crossband diffusion checkbox is selected, a weak diffusive term orthogonal to the streamline direction that reduces spurious oscillations is added. The consistent stabilization methods don't perturb the original transport equation. Now I'm going to go through the inconsistent stabilization. To display this section, click the Show button and select Stabilization. One inconsistent stabilization method is available: isotropic diffusion. Isotropic diffusion can affect the accuracy of the original problems, and isotropic diffusion checkbox is not selected by default for under-resolved problems. This option can be used to get a good initial guess. Advanced settings. To display this section, click the Show button and select Advanced Physics option. Select Non-Conservative or Conservative from the Material Balance from list. Non-conservative is selected by the default and does usually not need to be changed. Particle properties. The particle properties section is used to specify properties of the particles in the population. Enter value expression for the density and molar mass in the particle density and the particle molar mass fields. Select the particle shape. From the particle shape list, select spherical for spherical particle or cubic for cubic particle. For user-defined, specify an area shape factor and volume shape factor in the corresponding field. These properties are used for calculating additional variables such as particle volume and when using certain predefined nucleation and growth rate models. So these properties are used for calculating additional variables such as particle volume and when using certain predefined nucleation and growth rate models. Size interval. Select the size discretization approach from the discretization list. Select linear to use a linear discretization approach. For a non-linear discretization, you can select logarithmic or geometric. For all operations, enter the number of size intervals to model the number of interval fits and the smallest and largest size to model in the minimum size and maximum size field. For the geometric option, also enter a finite constant and geometric constant field that controls the size interval width. Nucleation section. Select an option from the nucleation rate list to add a particle source to the smallest size interval. Three different options are available: user-defined, Arrhenius expression, and homogeneous nucleation. The first one, growth and dissolution. Select an option from the list to apply a growth and dissolution rate to all intervals. The options that are available are user-defined and transport control. Select user-defined to enter value expression. When this option is selected, the text field also accepts an expression written as a function of the particle size. Then solving will be replaced by the discretized particle sizes. Separate text fields are available for growth and dissolution. A positive growth rate results in particles becoming larger, while a positive dissolution rate results in particles becoming smaller. Select transport control to define a growth and dissolution rate that is limited by the transfer of the dissolved species. Aggregation. Aggregation section. Select the Include checkbox to include aggregation. When selected, enter an aggregation kernel in the aggregation kernel field. The field supports expressions that are functions of the two colliding particle size and pop.lk. Breakage section. Select the Include checkbox to include breakage. When selected, enter a breakage rate constant and average number of particles resulting from breakage in the breakage rate constant and average number of resulting particle fields respectively. Dissolved species properties. This section is only visible when additional information is requested by the growth or nucleation section. This is when homogeneous nucleation is selected in the nucleation section or transport control is selected in the growth section. Intervalue or exposure in the concentration, equilibrium concentration, and diffusion coefficient fields. Discretization. To display all settings available in this section, click the Show button and select Advanced Physics option. So thank you so much for watching my tutorial video until the end. Today is 16th of no, May 2026. Time is 10 o'clock in the morning.